I want to do just like a brief discussion of sort of what is AI when we talk about AI. These will mostly be just some definitions around terms you might hear people toss out. I know for some of you this might be a little bit of a refresher or a little bit backwards. If we just skim through the recording to make sure you understand a lot of these, because we will be bringing these up a little bit as we go through each model over the next couple weeks. So first thing I want to talk about is just sort of, you might hear about people talk about deep AI. There's very little, I've yet to hear people call what the opposite of deep is, so I'm calling it shallow AI. And what deep AI really means is sort of neural networks. Deep AI is the idea, and we'll get into this more when we talk about the actual models we use. There are different layers of models, or different layers inside these networks, and those layers can help do more complicated things. So usually you'll see this in regards to image and text generation, but also for classification. The key thing to sort of know about is that as of a couple years ago, they required like some pretty important like computers, or like access to computers that you wouldn't normally have. Like your laptop wouldn't have worked back in the day. That's kind of changing now. And a lot of people, I think, are moving away even from these sort of deep and shallow discussions. But one thing I think is kind of important here is that a lot of companies will claim they use AI, but what they really mean is they're using like shallow stuff, like like linear regression, or I've seen people even say like scene detection is AI, and it's like there's no AI model in that; it's purely computational. But regardless, like you might hear people talk about deep AI, and that actually isn't really that important of a concept anymore these days. It just means the way the model is made has different layers to it, and that's what they mean by deep. So lots of people will promote these as sort of they're doing a lot of deep AI, but they're really not actually. And that gets like this complicated question of like how much do you overpresent or describe what kind of AI your company's doing. I talk about that in another section of this week's lectures, but it is a nuanced thing that maybe even when you're looking to join a company, it's important to know like what kind of AI do they actually do, and will that affect like how you sort of work with their models and their tools and that sort of thing. Again, I think we're kind of like, I feel like for maybe a year or two there, we're not talking about this, and now we're back to talking about this, which is just, a lot of people have these complicated feelings about AI taking over the world. You hear a lot of discussion about AI safety and, what are we making? These tools are too smart for their own good, that sort of thing. And I just kind of want to debunk some of that concept, some of that theory, or some of those concepts, at least from my point of view. So you might hear people talk about AGI, or general AI, and that's generally this idea or this concept of like these AI models becoming so smart they can take over the world, right? So that's robots, supercomputers, the Terminator. And quite honestly, from my perspective, that's fiction. Like we are very, very far off from that. And we've been very far off from that. People have been talking about this for 50 years now, and we've barely scratched the surface of what these things can actually do. Even some of the advanced models we'll look at in this class, where you might think there's quote unquote intelligence in it, aren't really that intelligent. They might just be trained on a lot bigger data set, and therefore they look a little bit smarter. So in general, my perspective is don't worry about this. It's not a real thing, and anyone that's sort of running around posting every day about how dangerous all these tools are is, I don't know, maybe a little off the rocker. Instead, what we're going to talk about mostly in this class is what we call narrow AI. And narrow AI is really more task-based. And I like to talk about this as like, previously I've talked about this as like one tool for one specific purpose. And while there are now models that are doing a little bit more in terms of being able to do more than one thing, I think you can still sort of argue that it's actually a bunch of models that tie together to do one thing. So these are limited tasks, right? The idea is that you can enter in a text prompt and get out an image, or you can enter in a text prompt and get out a piece of text, or you can classify a set of images into 10, 100, 1,000 categories. The goal here is that there's an input, meaning there is something you feed into the model, whether it's text or an image or whatever, and you get something out of it. And that out of it is usually one format as well, right? It's just text, or it's just images, or it's a class. And this is a really important concept, because I think as you begin to work on AI tools yourself, you'll want to make sure you understand the exact input and output to be able to help generate and guide our users into using those tools. So in the model creation process, again, we'll talk a lot about models over the next couple weeks. Think of a model as just the sort of the logic that determines how you take an input and convert it into an output. We'll talk a little bit more about this in a couple minutes, but essentially the process to make these tools is you start with a big data set, you then do what's called training on that data set to create the model, and then you do what's called inference. So let's go through these steps one by one, just so I can help sort of explain a little bit of what we're going to be looking at over the next couple weeks, and why this is important for you to be aware of across the various parts of this experience. So first, let's start with data sets. So usually when we talk about a data set, someone thinks about their data on Facebook, or their data that is across the internet on various websites, or that someone can pull from them, right? We think about it as sort of a very personal piece of ourselves, or of our lives and our data. But in reality, most companies don't care about an individual user's data set. They care about a lot of data. I think maybe a decade ago we used to call this big data. That was the big hype term of the era. So the idea is more that Facebook has millions and millions of customers' data, right? They have what their name is, their birth dates. They know as much as how much you spend on your credit card per month. Lots of data around customers, and this is really what is actually fueling a lot of the AI tools today, is that we just have access to way, way, way more data. So OpenAI's ChatGPT is trained on an unknown amount of web data that it's crawled, right? So it goes to every single website across the internet, pulls all the text data down, and then uses that to train their model. And we'll talk about the ethics of that in a minute. But it's important to understand that really what we're talking about here is just massive, massive amounts of data, more than you or I could collect individually, in which case a lot of these companies are building massive scraping systems to be able to pull all this down. So the more data you have, the better off these models are going to be, within reason. But this is sort of the key part of this. In a lot of the tech classes that I teach is a lot of image data, right? So this applies to text data. It applies to maybe tabular data. So say, again, with a customer's data, you could look at all the various different rows and columns of their information. And then it also applies to images. Images are essentially rows and columns of pixel colors, which is pretty fascinating, and why some of the image tools work as well as they do is because of those processes, and also decades of computer vision research. So what we need to do is we need to collect a data set. Now, we're not going to do a lot of training in this class. We'll mostly use off-the-shelf models just for your awareness. But it's likely that if you are working with a engineering team, a research team, or with product folks, you will probably at some point need to build your own data set. It probably won't fall on you as an individual, because it's not really the job of a designer, but it's worth being aware of. And actually, I know that there are designers working in these spaces to actually begin to help teams build data sets and create interfaces for data sets. I'm hoping, fingers crossed, maybe we can talk to a person or two about that as we do these interviews. But data sets are really the core underlying meat of AI tools, and also where the most ethically problematic areas exist, and we'll definitely talk about that. So once you've got your data set, we're going to need to do this thing called training. Now, training can differ depending on the tool, depending on the model, depending on what you're doing with it. But at some point, you basically take this data and you pass it through to, in most cases, a neural network or some other system for creating a model. And again, this can be a little bit generic, because we'll look at a different case of these within each tool, and they will be different depending on the tool you use or even the model you're trying to train. But anyway, this gets passed through this training process. Now, in some cases, this can take minutes to train your model. In other cases, it can take days, weeks, and months. The OpenAI team who trains ChatGPT, I think it takes something like months in order to train their models. And that's just because they have so much data. So either way, you're going to go through this training process. Again, we will maybe look at some training processes here for very lightweight things in this course, just so you can get a sense of how it works. But we won't really go too deep into the training process. But the goal of the training process is to get this thing we will call a model. Now, I've kind of drawn it as a black box here, because in some ways it is a black box. Not always, but it is not the most legible thing. Like literally, if you were to open up one of these model files, you'll just see a bunch of numbers. And I don't mean numbers as in like bytecode. I mean literal numbers as in like a floating point number. And there's like millions of them. And that's actually the layer weights, or the weights of nodes within layers. If you're interested in this, I've got some other videos that will cover this sort of topic, but all we need to know for our purposes is that most AI tools rely on a single model or multiple models that are chained together, and that by having this model, we can now do what's called inference. And inference is actually probably the thing that's most important to us as designers, because this is where we actually see our users be able to leverage our models to create whatever they're trying to achieve. And for this, I should have mentioned this. This is actually a great video on covering training. So if you're ever interested in this, this is this series from this group called 3 Blue 1 Brown, which does a lot of math videos. But this video on neural networks is actually really great, and I would highly, highly recommend watching it if you're interested at all in this. But what I really want to talk about is the inference. So inference is kind of a fancy word for basically using the model. We call it inference because it comes from the data science place, where this is us testing and retrying and experimenting with our model to make sure it works the way we expect it to. Now with inference, there is an input, right? And that input, let's say in the case of ChatGPT, is actually text. That input in the case of more image models might be images or multiple images. I might show a little video at some point of horse to zebra, where you put in a horse and a zebra image and you get out a blended model of those two. And in fact, maybe a good example of this is Keelan's trash baby. So this week's interview will be with Keelan, and she can show off like the trash baby tool she has, where you upload two different images and it kind of merges them together. So the key thing to know about with inference is that there usually is a very specific type of input. The input has to be an image, or the input has to be text. And that will be defined by your model, and that will be defined by your engineering team, although it might be predefined by you if you decide like, hey, I want to build out this tool and it needs to start here and do this. So there's always an input, and that input is pretty much forced into a certain type of product. That then gets passed to the model. And from that model, you then get your output. And in most of the classes I've taught before, the output is an image. But again, if this is ChatGPT, the output might be text. If this is a classification model where you're trying to determine objects that are in an image, it might be a list of different objects that it sees. But this is essentially the AI pipeline, and this is sort of what you will see most commonly. So when people just throw a text field onto a page and say like, enter in a prompt, the input is a piece of text and the output is, whatever it's trying to build. Now what's important here to understand is like, this doesn't mean that you are necessarily tied to using text as your input. You could think about, chaining this with another model that maybe takes an image and describes the image. So this is, again, sort of maybe like Keelan's poetry camera, where the idea is it takes a photo, it then uses a AI tool to describe what's in the photo, and then converts that description into a piece of poetry. So you can chain these together. And again, as you think about building out what the best use cases for your customers, you might want to think about chaining and leveraging multiple of these models. If this isn't making a lot of sense, this will make a lot more sense when we actually just start building stuff or start playing with it and looking at different models. So we'll do some of that starting next week. Another thing that you might hear people talk about is generative AI. Generative AI has become sort of a common tool for a common phrase when people describe whether a model creates something or not. So obviously the generative part is that it creates a thing. And this is often text or images. It could create sound. We actually won't look at any sound tools in this class, I realized. We could look at sound tools. Maybe that'll be week 6. If anyone's interested in that, I'm happy to show some examples of that. It could create sound. I don't know. There's no place where it creates smells or food yet, so I don't know. We're not there yet. But sensory data, right? Text, images. Classes are not considered generative, and that's part of this model series called discriminative models. So when we talk about classifiers next week, we'll talk a little bit about what discriminative means. That just means that they are actually like choosing between a set of categories, or defining between different pieces, like what is in the image. And that's usually predefined by the model. So most models in a discriminative category are given a set of classes that they must choose from. So maybe it's cat or dog. Maybe it's, human or not human. Or there could be multiple classes, right? It could be cat, dog, fish, plant. And the important thing to know about that, as we'll talk about a little bit more next week, is that those predefinitions are actually sort of fixed. You can't change it without retraining the model, essentially. So the key thing that I think is important here to understand is just how much this model process, this model pipeline, can change a lot of how designers are used to or accustomed to building out sort of experiences and processes for customers. So let's talk a little bit about sort of like the traditional product workflow. Usually these start with a user goal, right? Like I want to write an email newsletter. With that user goal in mind, we, the designers, go out and spec out like what that means. Now, maybe we go and do some research to actually redefine that goal or like narrow it down a little bit more. But then we create like a UI based on that goal, right? Okay, so hey, you want to write an email newsletter? Well, that means we're going to need a field for headline. We're going to need a field for the body copy. Maybe in that body copy you can place images. Maybe we separate the images and just have image sections, like different things. And then the goal of this is like you work with your product team to define what that logic looks like in the center, right? So if this, then that. So, you start by adding a headline. After the headline, then maybe you like switch it to body copy. But the goal here is that there's like a defined set of steps, right? And these steps can change by changing your code, right? So if you say, hey, actually, for whatever reason, we want to always have the headline be the third paragraph in the newsletter, and then we want to have 2 paragraphs ahead of it that do something else. That's then definable by the engineering team. They say, okay, well, we'll move some of the code around and make that always the case. So this is like a traditional product design. And I think what's really important to understand here is that like this is defined by this like fixed logic that you can expand by adding if-else statements or other software techniques, but that it is defined. Somewhere someone has written all of the different logic and all of the different rules and embedded that in the code. Now that differs from the AI world. Well, actually, let's talk a little bit about what the pros and cons of this are. So, obviously this logic is controllable, meaning you and the product team like have defined what actually happens in these tools. And this is iterable, right? You can change things. You can see like, oh, we're seeing lots of customers want to put an image first in their newsletter. So let's actually create a field at the top of the page that is an image. So you can alter the code within this system. And this control goes both ways. You can control it, and your users can also like understand like, oh, it's asking me to put an image in the first position, so I can always do that. Maybe I want to put a headline there, so I like hack around it by making text as an image and placing that in, right? So there are ways in which you can define this. Now, the downside of these tools, as we've known for years now, is that this is slow. This process does not happen overnight. It is an iteration that requires the input of product folks, designers, software engineers, et cetera, et cetera. And the other problem here is like, what if this just doesn't work for me and my use case, right? So this could be edge cases where, you have to go and define like, oh, for this type of newsletter, we want to do this thing. For this type of newsletter, we want to do this thing. So you're sort of forking these paths. You're creating new pieces of logic that will hopefully contain all of this. And this is sort of where we've sort of are today, is that we build out these very complicated logic flows. We have a large, massive rule set that defines everything, and this sort of becomes our Bible for how a product works. Now, we're starting to see that change, and that's because of AI. So let's say an AI product is also trying to say, like, the user goal is I want to be able to create an email, and I want to be able to create an email newsletter. Well, in an AI product, you might say, well, let's just start with data. Let's look at millions and millions of email newsletters that have already been written. So let's go and scrape MailChimp's data set, or maybe we're at MailChimp and they want to scrape the data set. And maybe you organize these things by certain things. Like, you happen to know what industry this customer is using, so you define it by industry type. Or maybe you also have other filters for stuff like, is this a marketing email? Is it a sort of newsletter email? Is it a promotional email? Is it a video only email? Like, there's no video only email. Is it an image only email? Like that sort of thing. So you start by scraping a bunch of data, and you basically say like, well, whatever people previously made using these tools is what we want to build again. So there's kind of an interesting thing here in that, like, this is always, I describe AI as always conservative. And the reason I describe it as conservative is it's always using data from the past. There is no fundamentally new version of newsletters that AI is going to be able to create, because it's based on existing data. Now, the other part of this is that once we've trained this model, we now have a model that can supposedly create newsletters. Maybe we just give it a category and a topic and a theme, and it can then go ahead and generate the newsletter for us. Now, the problem here is like, if it works, and that's awesome. But if it doesn't work, now we've got this whole like black box system of like, well, why doesn't it work? Is it because our data is poor? Is it because the architecture we built the system on, the neural network that we actually used to create the model from, is wrong? Was there just something going off in the model that didn't make sense? Our inputs not accounting for our outputs? This is the biggest problem we have, and this is the goal or the value of these things and why people are finding them so powerful is it's instant, or at least it looks instant to us because we don't see the months of training and of building these architectures. Now, the downside of these things, and things I think people commonly see, right? How many people have gone to ChatGPT and said like, oh, let me put in some content and like ask it for something, and what I get back is garbage. That like garbage is not something that you have control over. You can try to rewrite your prompt to ask for something better, but you might not get a better result with that way. And this is one of the bigger problems with AI, and like probably where we need more designers in the room. These iteration processes, like, hey, if this isn't working as we expect it to for users, then we have to go in and investigate how to fix it. Maybe it means more training data. Maybe it means a different model. Maybe it means just training the model for a longer period of time. It sort of is unknown. And this is the biggest problem that I see of frustrations for teams that are coming in and being asked to integrate AI. It's easy to build that first version that just says, oh, look, I give it a piece of text and I got an image. It's much, much harder to say, is that image of high quality, or is that image exactly what the customer is asking for? And again, that sort of like lack of knowledge about why something is working the way it is can be really, really frustrating to us as product designers, because we can't go in and say like, hey, just make a fork for this different use case. In fact, a different use case might actually need a different model, in which case you might have to go back and build things. So this idea that instead of making the rules and writing the logic, we actually have the machine make up its own logic is a really fundamental shift in how we work, and can be a big challenge to customers and how we think about using AI. So all that to say, like, as what we'll really be talking about mostly in this class is how to mitigate this problem, how to work around this problem, because I've yet to see anyone, even some of the most expensive and high value machine learning companies can solve this problem. This is often called like a transparency issue or an understanding issue. OpenAI used to have a really big team that was devoted to this, and they did some really, really cool work. And unfortunately, a lot of them all left a couple years ago. Many of them are now at Anthropic. I think we'll be talking to an Anthropic designer in the future. But this is a category area in AI that is a really big challenge, and it's because these models don't figure out logic in the way that you or I would. They kind of have their own way of figuring out logic. And this is, again, something like, I hate to use this example because it is a little apocalyptic, but the idea that, an AI might decide that humans need to be eliminated if we ask an AI to create world peace, and they might say, well, humans are the actual problem here. Let's eliminate them, right? Like, that's the opposite direction of how a human might think about it. But it kind of does describe these AI tools in a good way, which is that, like, they do sometimes make really funny logical conclusions, or they see things that we as humans don't see as patterns, and they latch onto those patterns. And this can just become a real sore point for AI designers, because you don't always have control of these things, and you might have to find mitigating ways to get around it. But that's also kind of why I think like designers are so important right now. We do have a bunch of tools that do weird things, and sometimes the best way to solve that is to not remove the model completely, but to work around it with a better UI, with better knowledge in UX, or just helping customers understand what these tools are. So it's just a very brief overview of AI. This will I hope all make a lot more sense after the first couple weeks of us using these tools. If you're brand new to AI, then you're probably like, none of this makes any sense to me. But we will talk about it a little bit going forward as we go through each one of these models.